There is a Soviet photograph of the moon that NASA studied and then quietly walked away from. It was taken 3 years before Apollo 11, from a spacecraft the size of a beach ball. It sent home a panoramic map of the lunar surface that the world has mostly forgotten. NASA took it seriously enough to hand the imagery to a contractor in Houston for a full scientific evaluation. The report came back in February of 1968. That report is the spine of this video. Everything that follows comes from it, and what it describes is not what you think. So, let's go look at it. The Lunar 9 capsule was a sphere about 60 centimeters across. The camera sat on top, about 2 feet off the ground. It turned slowly in place and unspooled a continuous strip of the lunar surface, like wallpaper. One full revolution took about an hour. There were 5 transmissions in 3 days. 2 were partial or unreadable. What remained were 3 full panoramas, taken on the 4th and 5th of February, 1966. The analysts at Lockheed Electronics never received the full set. They got 11 fragments, most of them from the 3rd scan. Even the 3rd scan was incomplete, short by 94 degrees. They had to reconstruct the rest from published news releases. But what they had was enough. The first thing they noticed was the tilt. On the first panorama, the spacecraft was leaning 13 degrees. By the second, 16 to 18. By the third, 21 to 23. Read those numbers in order. 13, then 16 to 18, then 21 to 23. The capsule was leaning further over each day. Something was pushing it. The next thing they noticed was the horizon. There was a small detail built into the spacecraft, 3 pairs of mirrors mounted around its body that gave the analysts the only known distances in the scene. Using those mirrors, they could measure how far away the visible skyline actually was, and the answer they got didn't match a flat lunar plane. What they found is that the apparent horizon, the line where surface meets sky in the photograph, was not the true horizon. It was higher, significantly higher on the right side of the panorama than on the left. On the right, the skyline rose 9.4 meters above the camera. On the left, 4.7 meters. The spacecraft was not sitting on a flat plane. It was sitting in a depression. The skyline above it was the rim of something. They went around the panorama every 10 degrees and measured the distance to that rim. They got 20 data points. The points fell on a closed curve. When they tried to fit them to a single shape, what came out was an ellipse 286 meters across the long axis, 216 meters across the short one. The center of the ellipse was 81 meters from the camera. The conclusion is in the abstract of the report. Plain language. The Soviets had not landed Lunar 9 on an open mere surface. The spacecraft had soft landed inside, near the edge of a crater. The maximum diameter of that crater was 330 meters, the minimum 210. The camera sat between 4 and 9 meters below the rim. They had dropped it into a hole. The report is careful here. It notes that the elliptical shape might not be the true shape of the crater. It might be the result of accumulated errors in distance measurement, tilt calculation, and tilt azimuth. But the radial dimensions, the analysts say, will be in the order of the radii determined, somewhere between 108 and 164 meters. Whether the crater is truly elliptical or merely circular and the data is noisy, the basic geometry holds. The spacecraft is at the bottom of a bowl. The bowl is hundreds of meters across, and the rim of the bowl is what the camera sees as the horizon. Take the surface itself. In frame D, which is the central frame of the third panorama and includes the largest scale close-up of the ground, the distance from the camera to the top of the image is about 2 meters. To the bottom, half a meter. The smallest particle the analysts could resolve in that view was about 1 millimeter across. The surface, at that scale, the report says, is very irregular and aphanitic, with a texture similar to vesicular basalt or scoria. Aphanitic means too fine-grained to see individual minerals with the naked eye. Vesicular means full of small gas bubble holes. Scoria is the dark, frothy lava rock you find on volcanic cones. The surface of the Moon, 2 feet from the Lunar 9 camera, looks like cooled lava foam. In frame F, the analysts noted that the surface appeared slightly more frothy than in the preceding views. In frame G, to the right of a small vertical scarp that runs across the left part of the frame, the surface appeared more coarsely textured and, in the report's word, rubbly. There's a small escarpment about 1 meter high cutting across the visible terrain just outside the spacecraft. There are linear features that earlier public releases had interpreted as veins or dikes. The analysts didn't endorse that interpretation, but they didn't reject it. They just noted that one of the linears cuts across the upper side of a craterlet at coordinates 47 degrees azimuth, 7 below center. There are details in the other frames that were never expanded in any press release. The largest visible rock fragment, near the top right of frame E, is about 30 centimeters long and 12 centimeters high. The report calls it a broken fragment. Several small craterlets, ranging from 5 to 15 centimeters across, scatter through the right half of the frame. The largest is at 50 degrees azimuth, level with the camera horizon. In frame G, the largest crater visible to the camera appears behind the third pair of dihedral mirrors. The center of that crater is 15 meters from the spacecraft. It is 6 meters across. It has a low rim around its perimeter, a small detail the report flags, because not every crater in the field of view does. A second crater lies near the horizon between 110 and 120 degrees of azimuth, 30 meters out, 4.6 meters in diameter. Both are inside the larger ellipse. The bowl is pocked with smaller bowls. The escarpment on the left of frame G, the one mentioned earlier, is described in the report as a small irregularity on the horizon, about 1 meter high, extending vertically across the frame next to one of the antennas. To the right of that scarp face, the surface is, in the report's word, rubbly coarser than the frothy bedrock visible elsewhere. The texture of the ground changes between one side of the visible field and the other within a few meters. The summary of all this, in the report's own conclusions, is that the surface materials in this area consist of a highly vesicular to frothy bedrock, with scattered particles up to cobble size, unevenly distributed over the surface. Bedrock, not regolith, not dust, not the loose powder that Apollo 11 would film 3 years later in the Sea of Tranquility. The report's word for what Lunar 9 was sitting on is bedrock. The particle size count was made in frame 3, where the view to the horizon was least obstructed. Plotted as a cumulative curve, the particle counts behaved oddly. There was a sharp deviation at the small end, which the analysts attributed to the rapid loss of resolution in tiny particles. There was another shift in the curve toward the coarse fractions at the large end. The report offers 2 possible explanations. One is the same resolution problem, this time at distance. The other is more interesting. The other is, in the report's words, an admixture of materials from 2 different sources. The coarser particles, the analysts wrote, may be fragments of the spacecraft littering the scene. Hold on to that sentence for a moment. In frame F, near the bottom, at coordinates 58 degrees azimuth and 2 below center, there's a large object that casts a shadow. Both Russian and US press releases had called it a rock. The Lockheed analysts looked at it more carefully. They noted the regularity of the outline and the high reflectance. The object is about 25 centimeters long, 10 centimeters in diameter. The report's interpretation is direct. The regularity of the outline and its high reflectance leads to the inference that it is metallic and could possibly be a mechanical portion of the spacecraft used in the soft landing. Higher up in the same frame, at coordinates 72 degrees azimuth and 9 above center, there is a second object. This one looks like a portion of a sphere. The analysts measured a radius of about 16 centimeters, which they noted would correspond to the radius of a pressurization tank attached to the original vehicle. In other words, the camera on Lunar 9 had photographed pieces of itself scattered around the landing site. There is a smaller version of the same observation throughout the imagery that doesn't get a single named object attached to it. The analysts noted, in frame F, a number of other smaller objects in the background that share the high specular reflectance of the two large ones. They didn't measure them individually. They couldn't, but they were there, present in the scene, scattered between the large debris and the horizon. There is also one specific observation the report makes about frame phone, the version of frame F captured during the first panorama, when the sun was lower in the sky and the spacecraft was tilted only 13 degrees. In the lower left of that frame, in an area not visible in the later third panorama version of the same view, the analysts saw a bright glare. They described it, plainly, as indicating an object with very high reflective power. They did not name it, they did not measure it, they did not match it to any visible piece of the spacecraft inventory. They photographed something extremely reflective on the surface of the Moon in February of 1966, a few meters from where Lunar 9 was sitting, and the report's only entry on the matter is that they couldn't tell what it was. The analysts ran microdensitometer scans across these objects to compare their reflectance to the surrounding terrain. The quality of the imagery was so degraded that the results were inconclusive. But they were, the report says, suggestive. The brightness levels of the suspected metallic objects were fairly constant throughout the frame, in a way the surrounding rocks were not. The number of suspected spacecraft fragments scattered around the bottom of a crater 200 to 300 meters across is not small. It's enough that the particle size distribution itself shows the contamination as a statistical bend in the curve. Now, let's come back to the crater. A spacecraft soft landed at the bottom of a hole on the Moon. Its camera, 2 feet off the ground, looked out across a frothy, vesicular surface that the analysts identified as bedrock. The spacecraft was tilted 13 degrees on the first day, 18 degrees on the second day, 23 degrees on the third day. 2 of its 4 landing petals were partially visible in the imagery. One, in frame A, was at 250 degrees azimuth on the original landing position. The other was in frame F at 70 degrees on the opposite side. The analysts compared the position of the petal in the first panorama to its position in the third. In the first scan, the petal appeared lower and barely visible above the camera horizon. In the third scan, with the spacecraft tilted further, the petal appeared higher, more fully exposed. The analysts wrote that the difference in position indicated the petal had been forced upward toward the camera. Their interpretation was that the petal was in contact with the lunar surface, and as the tilt increased, the surface pushed the petal up against the body of the spacecraft. Match that with what the opposite petal was doing. In frame A, the petal that was visible in the first panorama showed below the horizon. By the third panorama, with the increased tilt, the same petal appeared higher in frame, the latch mechanism more visible. Same effect, opposite side. Both petals being pushed upward by the ground beneath them. Something in the 3 days between landing and the final transmission was forcing the spacecraft to settle. The report doesn't say the crater was active. The report doesn't say much at all about what was happening underneath Lunar 9. By the final transmission on February 6th, the spacecraft had been tilting for 3 days, in a hole, on a frothy bedrock surface, with what looked like pieces of itself scattered around it. There's also the question of which way the spacecraft was facing. The line of lowest inclination, the direction the spacecraft was tilted toward, was within 10 degrees of the direction of the Sunday. The report notes this. It notes that the proximity is suggestive of some control mechanism used for orienting the spacecraft in a solar direction. The Soviets, in other words, may have been able to point the camera. The amount of control over the inclination and orientation of the tilt axis, the report says elsewhere, is purely a matter of conjecture at this time. We have one Soviet press release showing the capsule and 3 pairs of dihedral mirrors arranged around it. We have no confirmation of how those mirrors were oriented relative to the optical center of the camera. The analysts had to deduce it. When they deduced it, they found the second pair of mirrors and the third pair of mirrors were both right-angle dihedrals, mounted symmetrically with respect to the optical center. Standard, expected. The first pair of mirrors, the ones near 315 degrees in the panorama, was a right-angle dihedral too, but it was set at an asymmetric orientation with respect to the optical center. The two mirrors of the first pair did not face equally outward. One was angled differently than the other. The report's exact phrase is that the asymmetric positions may have been intentional or accidental, due to malfunction or damage on impact. That sentence is the closest the report comes to acknowledging that something might have gone wrong on the way down. Either the Soviets deliberately set up one pair of mirrors at an angle the others did not share, for some reason the report cannot identify, or the mirrors were knocked out of alignment when the capsule hit the surface. The analysts could not tell the difference from the imagery alone. The way the analysts confirmed the asymmetric placement is itself a small detective sequence. The other two pairs of dihedral mirrors had been straightforward to verify. Each one reflected a portion of the lunar surface 90 degrees out from its mounting position, exactly as a right-angle mirror pair should. The second pair, near 30 degrees, reflected ground at 300 and 315 degrees. The third pair, near 135, reflected ground that intersected the horizon at very nearly 90 degrees. The first pair, near 315 degrees, didn't behave that way. The analysts went looking for the boulder, reflected in mirror, one a distinctive promontory on the horizon, and could not find it elsewhere on the third panorama. The latch mechanism of one of the spacecraft's petals was sitting directly in the line of sight where the boulder should have appeared. They had to go back to the first panorama, taken when the tilt was only 13 degrees and the latch hadn't yet been forced upward, to find the boulder at all. When they did find it, the angle didn't match. The mirror image was 62 degrees to the left of the mirror, not the expected 90. They did the same exercise for the second mirror in the first pair. This one, by chance, shared a common point with one of the mirrors in the third pair, a small craterlet at 54 degrees azimuth, 4 above center. By cross-checking the two reflection paths against the same physical feature, the analysts could measure the actual reflection angles of the first mirror pair directly, without assuming anything about its mounting orientation. The numbers came out asymmetric. One mirror angled one way, the other angled differently. The geometry was wrong by design or wrong by accident, and there was no way to tell which. There is one more detail in the imagery that the analysts flagged but did not resolve. In frame B of the third panorama, just to the left of a prominent instrument in the center of the frame, at 277 degrees azimuth, there is a marked interruption of the imagery that looks similar to a mirror image. On closer inspection, the analysts decided it wasn't a mirror reflection. It was, they wrote, apparently caused by a malfunction in the telemetry system, a glitch, a piece of the picture that doesn't behave like the rest of the picture. They noted it and moved on. They had no way to verify it. Another note. The report identifies one frame from the second panorama, called frame B2, that the Associated Press had distributed as part of the second scan transmission. The analysts examined it and determined that it was identical in all respects to its counterpart in the third panorama, even down to the shadow detail. Their conclusion was that the original release was in error, and that the second scan photographs are in reality identical to the third panorama imagery. In other words, the Soviets, or the Associated Press, or someone in the chain of distribution had handed out a frame from the third panorama as if it came from the second. The Lockheed analysts caught it. The press release was wrong. These are the kinds of small forensic details the report keeps returning to. None of them, taken individually, prove anything. Taken together, they paint a picture of a spacecraft that landed in a hole, settled into bedrock, shed pieces of itself, gradually tilted further over 3 days and transmitted home a record of the process that the analysts in Houston could read but not fully explain. Crater size distribution was the last major analysis in the report. The analysts counted 44 craters that they could positively identify in the third panorama. 3 areas were sampled. The first, from 0.5 meter out to 2 meters from the spacecraft. The second, from 2 to 5 meters. The third, from 5 to 30 meters. Beyond 30 meters, craters were either not identifiable or too obscured for reliable measurement. The crater counts in each area showed a different size maximum, with a primary peak between 64 and 128 millimeters in diameter. The plotted distribution deviated from a clean, linear graph at both the small end and the large end. At the small end, the deviation was due to difficulty in distinguishing between true craters and surface vesicles, the gas bubble holes in the bedrock. At the large end, the deviation was due to the limited area covered by the imagery. The analysts noted that the total surface area covered by craters between 32 and 128 millimeters in diameter accounted for 7% of the surface. Craters between 128 and 1,024 millimeters accounted for 24%. Craters larger than 1,024 millimeters in diameter accounted for 18%. Roughly half the visible surface inside the crater was, itself, smaller craters. The largest crater visible inside the rim was about 15 meters in diameter. The spacecraft was sitting on the rim of a smaller crater 4.8 meters across. A crater at the bottom of a crater at the bottom of a crater. The visible moon, in Lunar 9's view, was layered with them. The analysts call this, twice, in different sections of the report, a specific local environment. Their conclusion in the abstract is unambiguous. The field of view from the spacecraft center is highly confined by the rim of the crater, and as a consequence, results of both qualitative and quantitative investigations should be recognized as limited to a specific local environment. Whatever Lunar 9 saw, the report says, is true only of the bottom of the bowl it was sitting in. There are things the report does not know. It does not know whether the elliptical shape of the surrounding crater is real or an artifact of accumulated measurement error. It does not know whether the asymmetric mirror placement was deliberate or the result of impact damage. It does not know what the high reflectance objects in frame F actually are, only that their reflectance pattern suggests they are not ordinary rocks. It does not know the function of the instrument in the center of frame B, only that it occupies the position of an antenna that was visible in Soviet press photographs but absent from any of the panoramas. It does not know what caused the telemetry interruption at 277 degrees azimuth. It does not know how much of the tilt over 3 days was due to settling, how much to slope, how much to anything else. It does not know whether the bedrock was vesicular because it was lava, or vesicular because it was something else. The report uses the comparison to volcanic rock as an analogy, not a claim. The exact phrase is that the texture is similar to vesicular basalt or scoria. Similar, not identical. The report is also careful about extrapolation. Its closing observation, before the final summary, is that the statistical count of craters was made over an area of less than 1/10 of a hectare, or a quarter of an acre. The analysts warn, plainly, that it is somewhat dangerous to extrapolate these figures to areas outside the immediate vicinity of the Lunar 9 spacecraft, a quarter of an acre. That is the entire ground truth from the first soft landing on the moon. Less ground than a suburban backyard. From that quarter acre, the world drew its first conclusions about what the surface of another world was actually like. 3 years after Lunar 9, Apollo 11 landed in the Sea of Tranquility, and the imagery the world remembers, the boot print in the powder, came home. The report's stated hope, in its own opening pages, was that the findings would serve as a guide for further investigation. That further investigation, on the Lunar 9 imagery specifically, does not appear in any prominent place in the public record. Lockheed Electronics Company, working out of Houston, under contract NAS 9-5191, prepared the analysis under the direction of the Mapping Sciences branch at the Manned Spacecraft Center. The report was issued by the originator as LEC/HASD Report Number 671400019. It was published by NASA in February of 1968 as Contractor Report CR 980. Distribution was provided in the interest of information exchange. Responsibility for the contents resided in the author or organization that prepared it. It was sold by the Clearinghouse for Federal Scientific and Technical Information in Springfield, Virginia for $3. That is all that ever happened with it. 68 pages of measurements, 31 figures, 7 tables, 11 photograph frames, analyzed in detail, $3. We don't know whether anyone has ever gone back to the original Lunar 9 telemetry, the unprocessed signal, and looked again. We don't know whether the Soviets ever published their own reduction of the same images. The report mentions that a press release from Moscow, made available at a subsequent date, contained a full panorama, which verified the reconstructed focal length the Houston team had derived. That is the only Soviet analytical document the report cites. We don't know why the spacecraft kept tilting. The report ends without resolving any of it. Somewhere in the archives at the Clearinghouse for Federal Scientific and Technical Information, or what its successor agency is called now, there is a thin paper document with the words Analysis of Lunar 9 Photography on the cover, and a barcode-style label that reads NASA CR 980. The document has been sitting there for decades. The original photographic frames, with their annotation overlays drawn by hand by the Mapping Sciences branch, are reproduced inside it. The crater rim is plotted. The mirror geometries are diagrammed. The petals are visible at the edges of 2 frames. The metallic objects are circled at coordinates 58 degrees, 2 below, and 72 degrees, 9 above. The spacecraft is still in the bottom of the bowl, tilted 23 degrees, where the last transmission left it on the 6th of February, 1966. It's still down there.